How does Euclidean geometry differ from non-Euclidean geometry? Have you ever wondered why geometry can look so different depending on where you are? Today, we are going to break down the differences between Euclidean geometry and non-Euclidean geometry. Euclidean geometry is what most of us learn in school. It focuses on flat, two-dimensional spaces and is based on 5 postulates laid out by the ancient mathematician Euclid. One of the most famous of these is the parallel postulate. This postulate states that for any given line and a point not on that line, there is exactly one line through that point that is parallel to the original line. This means that in Euclidean geometry, parallel lines never meet. You can see this in everyday shapes like triangles, circles, and polygons. This type of geometry is used in many practical applications, such as architecture, engineering, and land surveying. When you think of a flat piece of paper or a floor, you are thinking in terms of Euclidean geometry. Now, let's shift gears and talk about non-Euclidean geometry. This type of geometry studies curved surfaces instead of flat planes. It modifies or even rejects the parallel postulate, leading to different properties of lines and angles. There are 2 main types of non-Euclidean geometry: spherical geometry and hyperbolic geometry. Spherical geometry takes place on the surface of a sphere, like our planet Earth. In this geometry, lines are represented by great circles, such as the equator or the lines of longitude. A key point here is that there are no parallel lines because all great circles eventually intersect. If you think about triangles on a sphere, you will find that their angle sums are greater than 180 degrees. On the other hand, hyperbolic geometry occurs on a saddle-shaped surface. In this case, through a point not on a given line, there are infinitely many lines that do not intersect the original line. This means that there are multiple parallel lines. In hyperbolic geometry, triangles have angle sums that are less than 180 degrees. These differences also affect how special quadrilaterals behave and how the sum of angles in triangles varies according to the curvature of the space. To summarize, the main difference between Euclidean and non-Euclidean geometry lies in how parallel lines behave and the curvature of the space. In Euclidean geometry, we have flat space with exactly one parallel line through a point, and triangle angles sum to 180 degrees. In non-Euclidean geometry, we deal with curved space, which can have no or multiple parallel lines, and triangle angles that sum to more or less than 180 degrees, depending on whether we are looking at spherical or hyperbolic geometry. Understanding these differences helps us see why Euclidean geometry is perfect for flat surfaces, while non-Euclidean geometry is essential for studying curved spaces like the Earth's surface or even the shape of the universe.